Yes, welcome to a fact lecture. In the previous lecture, we have discussed some brief introduction of different type of fact controller. Either the controller may be connected in shunt, that is called as a shunt controller, that is statcom or static var compensator. Either it is a thyristor control or thyristor switched static var compensator. Similarly, in the category of series, it is a static synchronous series compensator, or it may be a thyristor control series compensator, or it may be a thyristor switch controllers, which we have already discussed. Now, the few points which was remaining as an introduction of different type of compensator, that is other controllers. The other controllers consist of one is thyristor control voltage limiters. So this voltage limiter is used to improve transient stability. It is used to improve transient stability. Okay. So what is that? It is a non-linear resistors which is connected. That is a gapless resistors are there, which is connected between line and ground. Under normal working condition, the voltage, the resistance offered by a non-linear resistor in such a way that it will make isolation between the line, transmission line and ground. Whereas under the transient conditions, it offers the path for to suppress the whatever the harmonics, whatever the traveling waves and traveling voltage or over voltages are there. So here, thyristor control part of the resistor can be connected through the thyristor control. So it is called as a thyristor control voltage limiters are there, isn't it? So which avoid over voltages in the transmission line. Next is the thyristor controlled voltage regulator. So voltage regulator, it is nothing but the tap changing transformer or OLTC, that is we are called as a on load tap changer of the transformer. So in case of overload, in case of on load tap changing transformer under load condition, it does not need to shut down the supply to change the voltage level. So under load condition, we can change, or we can provide some automatic system to control the voltage of the transmission line to maintain, say for example, it is 132 kV. We want to maintain that 132 kV voltage. And if the incoming voltage is 400 kV and the tapping is provided on the HV side, to maintain the terminal voltage on the secondary side, it is a constant one. So either it may be a mechanical switch, that is called, generally we have a OLTC transformer. As you know that in our college campus, we have installed the 500 kV OLTC transformer. So, but it is a mechanical switch. It is coupled with the some three-phase induction motor, and signals are given for increasing and decreasing the number of tap. The tap from number 1 to the 70 number taps are there. But it can be done with the help of some sophisticated method, that is SCRs, which avoid the switching or arcing phenomena inside the transformer. So it is called as a thyristor control voltage regulators are there. So this is somewhat a brief introduction or brief description of different type of fact controllers are there. Okay. Now, this is the checklist of the possible benefit from the fact controller or fact technology. In the very few lectures already, we have discussed that what is the objective of fact controllers or fact technology. It is first, in a two sentence, we can say that to increase or to enhance controllability and stability, isn't it? If we are able to enhance the controllability of the transmission line or a parameter of the transmission line, to enhance the power handling capacity of the transmission line, and second is to improve the stability of the system. Stability, it may be a steady state stability, it may be a transient stability limit, and it may be a dynamic stability limit. So this is one way. And to enhance the power handling capacity up to its thermal capacity, isn't it? Because we never operate the transmission line to its thermal capacity, isn't it? So there are some few points which is related to the FACT technology. First point is the control of power flow as ordered ensure optimum power flow. It means that our objective to increase the power handling capability of the existing transmission line in conjunction with the FACT devices, isn't it? Because we do not have land to erect one more transmission line, isn't it? May be very difficult or it is very costly to increase the installation of the transmission line. Second, the generation pockets from the western region, and whereas the load pockets are in the generation pockets are the eastern region, whereas the load pockets are on the western region. To transmit the power from a long distance, it is necessary to improve the power handling capacity and steady state and transient stability of the transmission line. It is very much necessary to use the FACT devices. Either we can go for the HVDC, isn't it? We will see what is the difference between HVDC and FACT technology. Okay. Second, increase the loading capability of line to their thermal capability. We have just discussed that there are different capability of the transmission line. One is the stability point of view. Second is the thermal ability, or that is a thermal capacity of the transmission line. And third is the dielectric strength. So dielectric strength, which is related to the type of insulator we are using, or 11 kV, it may be a 400 kV or 765 kV. So here, if you are moving toward the more than 765 kV, definitely we have to think toward the dielectric stability. Whereas the thermal stability depend upon the amount of current which is going to flow from the conductor and climatical condition, or just a geographical condition where the transmission line has been erected. So our objective to increase the loading capability, at that loading capability is simply it is P is equal to E1 upon E2, or it is as we have already derived one equation for the parameter of transmission line for the different voltage level, 0.5 E square, where E is the system voltage, divided by L into X, where X is the reactance per kilometer, L is the length of transmission line in kilometer, and sine delta we have considered as it is a 0.5. That is a sine delta is equal to 30 degree. So to increase the power handling capacity or power handling capability of the transmission line, definitely as the distance increases, the power handling capacity decreases, isn't it? To avoid this decrease in power handling capacity, we can use the FACT technology to improve the loading capacity of the transmission line. This is the second aspect for the FACT technology. Third, increase the system security through the rising transient stability limit, limiting short circuit current and over voltages. This is one more important, increasing the system security. If the system will be secured only when the system is stable, we can increase the angle delta as long as the system is stable. But we always operate the system less than the calculated value. Suppose the calculated value is 70 degree, but we never operate the 70 degree. We operate our angle delta. It is less than the calculated value for the stability point of view, for the security point of view. And therefore, our objective to use the FACT technology to increase the system security, that is the security of the grid, to avoid the cascade tripping of the power generating units, isn't it? And the transient stability. So by using the FACT devices, we can improve the transient stability. We will see in the upcoming some lectures are there how we can improve the transient stability with the help of FACT devices. Okay. Short circuit limit and the overloads. So these are the some few points which can be obtained with the help of FACT technology. Provide secure tie line connection to the neighboring utilities and region, thereby decrease the overall generation reserve and requirement on the both sides. This is one important in addition to this security. So up to this point, the no doubt it is possible to connect a number of generating stations together. because the generating stations are far away. These generating stations are site as per the availability of the natural resources, that is a coal, it may be a water, and land availables are there. And for the hydropower plants proper, we have to study the river, that is called as a river history or hydrology of the river, and then it is possible to erect the hydropower plants. So these power plants are very at a long distance from each other, and it is necessary, and thereby by using that FACT technology, FACT devices, it is possible to do the connection between the neighboring utilities, that is the neighboring generating stations nearby or some away from away, the neighboring stations are there, which will reduce the reserve capacity or reserve requirements. It means that suppose we are operating the system independent. This is Maharashtra is operating independently, Gujarat is operated independently. Definitely in Maharashtra, we have to keep some reserve capacity under some contingency, like there is maybe a failure of the one generator. Suppose had Deepnagar power plant is failed, therefore there should be some reserve capacity in there in the Maharashtra to provide the power during that situation, failure situation, isn't it? So what we are doing, we are keeping a one reserve capacity in the Maharashtra and one reserve capacity in the say Gujarat, some Madhya Pradesh, and so on. So if you connect all generating station, there may be a less chances that there is a failure, simultaneous failure in the generating station. So here, by using the interconnected system, it is possible to reduce the reserve capacity everywhere. So reducing the reserve capacity means infrastructure we are reducing. We are reducing the salary of the people, those are appointed over there. So there is some technical as well as economical advantage to reduce the reserve capacity in the system. So the next advantage of the FACT devices or FACT controller is to, our objective is to reduce the reserve capacity everywhere. Next point is provide the greater flexibility in siting the new generation. It means that when you are siting the new generation, means you are going to erect a new generating plant which is far away from the load center. For example, we want to erect a micro hydel power plant, okay, which is a power plant. It is from the northeast region, but in the northeast region the consumption is very less, but there is a potential to generate a few megawatt of power with the help of flow of river, because in the summer season the water, ample quantity of waters are there, isn't it? Say melting of ice and all, because of all these things. Okay, so now because of this power plant which is sited far away from the load center, and it has to be evacuated, power should be evacuated, that is power should be transmitted from the northeast region to the load center, but the distance is very high. So to avoid the losses by increasing the EHV transmission line, again the FACT devices can be used, and that FACT devices are is a very say we can say that useful for transmitting and the flexibility to erect a power plant in any location. Okay. Next, reduce the reactive power flow. Our system, generation system to the load center, the transmission line is not designed for using the kVA reactive power only. It is designed, say, for the kilowatt. Our objective to transmit the active power only, isn't it? If you are more the value of kVA, it means that the reactive power is more, therefore the kVA is go on increasing. So if with the help of FACT devices, it is possible to inject the reactive power. Say, suppose we have installed one reactive FACT devices at here. So it is going to inject the reactive power to the load, and transmission line is used only to deliver the active power. So our objective with the help of FACT devices to reduce the reactive power flow, kVAR, reactive power flow, or MVAR, reactive power flow over the transmission line, which can be used to handle more active power. So it will increase the active power handling capacity of the transmission line. So this is one more advantage to use the FACT technology. Increase utilization of lowest cost generation. What it means, it is very important to understand. Say for example, this is one generating station, this is second generating station, this is third one, and load is here. So if you are supplying the power, one more generation is here, say G1 is generation here, G2 is here, G3 is here, G4 is here. This is the hydropower plant, this is say thermal power plant, this is thermal power plant. So here, if you are going to supply the power from this two generating station, no doubt the distance is very small and the wheeling charges or the power loss during the transmission is small. But here the generation cost is very small for the hydropower plant. Say here it is some solar power plants are there. So the generation cost for the solar power plant and hydropower plant is very small, but the transmission losses is very large. And we can say that whatever the amount of power is going to generate, it is not possible to reach the same amount or less than some amount is not possible to reach at this point. The reason is that because of the length of the transmission line, because the stability point of view. So with the help of FACT devices, it is possible to evacuate the power, to evacuate the energy even from the long distance, and hence we can select lowest cost generation, isn't it? And it is done by the energy exchange or some energy exchange markets are there in India, or it is going to decide by the load dispense center from where we have to get the power, which is the lowest cost of the generating one. Is it clear? So this is the some possible benefit from the FACT technology or different type of FACT controller. And this may be obtained either by connecting the shunt compensator, it may be a static series compensator to get these benefits from the FACT controller. Now, see the control attribute for the various type of controllers are there. What it means, then in this column, there are different type of FACT controller, and their control attribute means which type of parameter is going to control with the help of a FACT controller. Say for example, we'll see a few of them which already we have discussed in brief, but at a glance it is quite simple to understand. Say static synchronous compensator. What is a static synchronous compensator? It is connected in parallel, either at the sending end, mid of the transmission line, receiving end, without storage one. Means either it is a voltage controller, voltage source or current source, isn't it? Generally, we are using the voltage source converters, voltage source converter based STATCOM. What is the objective and what are the control attributes are there? It is voltage control. It will do the voltage control because as it is connected in parallel, so it inject or consume. If it is a say capacitor, it is going to deliver the reactive power kVAR, and if it is an inductor, it is going to consume the reactive power, surplus reactive power in the transmission line because of the length of the transmission line and capacitance of the transmission line to maintain the constant voltage. So this is the one objective which we obtain. It is a control VAR compensation. VAR, it is either it is a capacitive reactance or it may be inductive reactance, can be compensated. Damping oscillation and voltage stability. So as we are in obtaining the voltage control, definitely it is we can avoid the voltage collapse or we can improve the voltage stability and damping oscillation. Whenever there is a transient or there's some sudden disturbances, sudden perturbation in the power system, the new equilibrium position, to reach up to the new equilibrium position, there are some oscillation. After first swing, there is some few oscillation. As the system is interconnected, this oscillation will take more time to settle. This oscillation, this more time of oscillation may lead to the instability of the system. To avoid this unstable region, it can mitigate the oscillation and quickly the system settle to the new equilibrium points. This is the attribute of. Second is the static compensator. with energy storage system. Okay, this energy storage system may be a capacitor which we have used. Either it may be a say a superconductor type energy storage system. It is used, voltage control is same, var compensation, damping oscillation, transient and dynamic stability. So this is one additional points comes into the attributes. What is that? It is to use to improve the dynamic stability and the transient stability, which I have earlier explained. So dynamic stability is the brief period where the system behave to reach its equilibrium position. Once there is a transient is over 1.5 cycle, it will take some few cycle to reach its equilibrium position. And the dynamic stability is the study of system during that time. So dynamic stability is going to observe in this brief period of time. So it will improve if suppose there is some energy storage system. This energy storage system may boost the energy during deficit of the active power, or there may be a surplus of the active power, and it will improve the transient as well as the dynamic stability, voltage stability as same, and automatic generation control. So this is the some attributes. Now static var compensation. There are three or four type of static var compensation. Static voltage regulate, static voltage control, that is a TCR, Thyristor controlled reactor. What is the Thyristor controlled reactor? This is the reactor, and it can be controlled with the help of reactors. Okay, so here it can be controlled with the help of reactor. So there is a smooth variation. There is a Thyristor control switch. Either it may be a alpha is equal to 0 and alpha is equal to 180 degree. So then it will become a Thyristor switch. This will become a switch. Either it is going to conduct 100% or it is a stop. So it acts as a Thyristor control switch and Thyristor control reactor, and Thyristor control, it may be a capacitor or this one. So it is used as it is, again it is connected in parallel or it is connected in shunt. So voltage voltage control, var compensation, damping oscillation, transient and dynamic stability, and voltage stability. So it is somewhat less costlier. So it can be used in the system. Now Thyristor control braking resistor. I think it was that point was remaining. What is that? Again, it is used for the damping oscillation and dynamic stability. During transient condition, this is the during this transient condition, what happens? We can connect a braking resistor, or we can connect a resistor to avoid the power should be 0. Means if you, when you go to the equal area criteria, I think you have learned this equal area criteria. If suppose the fault occur at that point, the power goes to the 0 value, isn't it? And when the power goes to the 0 value, the mechanical input is same, whereas the electrical output is 0, and the generator accelerating. To avoid the generator accelerating, we can use the braking resistor in conjunction with the say it may be some circuit breaker and so on. We'll see in the detail, but it is used to improve the dynamic stability or dynamic oscillation, transient stability, and dynamic stability of the system. So this is the some attributes, that is a fact, different type of fact controller and their attributes. Next, statics synchronous series compensator. Definitely it is connected in series and it is called as a line length compensation. Our objective to decrease the total transfer reactance of the transmission line, which will increase the power handling capacity of the line. Say this is the one without compensation and this is with the compensation. So this is the power P which has been increased, and this with the help of series compensation. So this is first is the without storage system, and second is the with storage system. So it is going to control the current, damping oscillation, transient and dynamic stability, voltage stability, and fault emitting currents. So it can be done with the these parameters. Similar control, current control, damping oscillations, transient and dynamic stability, both are there. But here it is used especially for the dynamic stability improvement. It is used for the dynamic stability improvement of the system when the static synchronous series compensator is conjunction with the synchronous with the some storage system. Next is the Thyristor control series reactor. There are TCSC Thyristor control series compensation and Thyristor switch series compensation. What is that? Already we have done. This is the line, and in series with the line, say this is the line. In series with line, we have connected a capacitor, but the capacitor is controlled. Their effective value is controlled with the help of Thyristor control reactor. Now here we have connected one reactor in shunt with the transmission line and capacitor of the transmission line. When it is going to control, the firing angle is going to control from its different value. Definitely some part of the current is going to flow from here and some part of the current is going to flow. So we can obtain the variable capacitor value. So therefore it is called as a Thyristor control series capacitor, Thyristor control series capacitor. And when the capacitor, when the Thyristor is used only for switching operation, alpha is equal to 0 and alpha is equal to 180 degree or 90 degree, then it acts as a switch. So it is a Thyristor switch series capacitor. So it is a one kind of SVC. The SVC is less costlier. Similarly, the Thyristor control series capacitor also the less costlier as compared to the static synchronous series compensator. So the attribute is same as the series one. Now Thyristor control series reactor, similar to the capacitor, we can use a reactor in series with the transmission line, and it can be done the control with the help of Thyristor control one, and it can be do same way as we are doing the in case of capacitor. So during the surplus of reactive power, or to avoid this phenomena, say interferenti effect and all this one, we can use this such type of this one and limiting the fault current. This is one more. It can limit the fault current in the system. Okay. Now Thyristor control phase shifting, which we have already just discussed. With the help of shifting transformer, it is possible to change the angle delta, and by improving the power handling capacity. Active power control, we can control the active power here. Till now we are not going to control the active power, but here we can control the active power. Damping, oscillation, transient, and that is all three type of stabilities we can do. Next is the unified power flow control, which is going to control the active series and shunt compensation. So the control attribute is the combination of series and shunt controller. See here, it is the active and reactive power. Though both are going to flow because there is a DC link or unified control over there. So we can control the active power between the two transmission line or in the single with the help of shunt compensation and series compensation. Voltage control, VAR compensation, damping, oscillation, transient and dynamic stability, voltage stability, and limiting current. So we found that in case of unified power flow control, controller, the combination of series and shunt, whatever the attributes which is we have discussed in the shunt and series, both are included in the this type of controllers are there. Okay. Now Thyristor control voltage limiter. Just we have in this lecture we have seen this is the voltage limiter. This is the transient and dynamic stability. In the transient condition, the voltage of the system going to oscillate, or in the transient condition there is a sudden change in the system. So this transient voltage, it is going to die out with the help of say nonlinear resistors, or it is also called as a it may be called as a metal oxide varistor. Due to this metal oxide varistor, under normal working voltage, it offers the proper isolation between ground and line conductor, but during transient condition, the over voltage is safely transmit to the or safely grounded very well. Okay, so this is now Thyristor controlled voltage regulator. This is nothing but the simply it is a OLTC transformer. But in case of our OLTC transformer, which we are using our substation in 11 kV or 33 kV, it is a mechanical operation. but it can be done with the help of thyristor valves. And with the help of thyristor valves, again, the life and the proper switching operation can be obtained. And one more thing, in that case, it inject the voltage in series with the line. So whatever the phase voltage are there, phase voltages are there, in the same direction, it will inject the voltage to maintain the voltage profile of the transmission line. So when we are maintaining the voltage profile of the transmission line, it means that we are handling the reactive power. We are going to optimize the reactive power. So with the help of thyristor control voltage regulator, it is possible to do the reactive power control, voltage control, damping oscillations, transient and dynamic stability, and voltage stability. So these are the some attribute of the system, different type of controllers over there. So in the next time, we will see what is the similarity, or what we can say that it is not the comparison, but some say a basic difference in the FECT technology and HVDC technology.